So, in computer science, an agent is an autonomous entity that observes its environment, collects information, processes it, and takes actions to achieve a specific goal, and then continues. What has changed in recent years is we have unlocked new capabilities. We gave agents access to LLMs, to the reasoning engine. So, Andre, what is the Agentic Web then?
All right, great question, Kasper. An Agentic Web is not a separate web. It's an evolution of the web that we already know and love. It's primarily built to enable humans to create, share, and consume content, shop online, and all of that, all the things we already do. The difference is that users are increasingly using AI agents to perform those tasks. On the Agentic Web, an AI agent can come in different flavors. You can have on-site agents, which are integrated directly into your website, part of your experience. You can have a browser agent that can be native to the browser or created via browser extensions. And you can even have off-browser agents, like CLI applications that can talk to the browser via protocols like CDP or DevTools and WebMCP. So today, we are talking about browser agents, native to the browser, like Gemini and Chrome, or provided via browser extensions like the Model Context Tool Inspector you're going to see later today. If you're interested in other kinds of agents, come find us after the workshop. We are happy to have a talk. So, as developers, we want to enable our users to succeed when using our site with AI agents. To do it, it's important to understand how agents see our website, or what kind of inputs it will collect from our pages to understand and action on it. So the first way an agent can do it is by literally looking at your page. It does that by taking screenshots of the rendered page and then using a vision model, just like a human would, to interpret it. Then the agent can also read the renders DOM and analyze the structure of the text. So the nesting of elements in the DOM, like a button inside a div, tells the model about the hierarchy of the text. It will also use the raw text to make sense of the content and understand actions it can perform. Like the text inside a button tag, for instance, tells the model what the button does. So the DOM tree fundamentally reinforces the relationship between elements in your page. Finally, the accessibility tree. The accessibility tree is a browser-native API that distills the DOM into what's most important: roles, names, and the state of interactive elements. And it provides the agent with a semantic summary of the page. It's also what screen readers use, by the way. So, as it happens, making your website great for humans will also make it great for AI agents. If you do high-quality visuals, semantic HTML, reinforcing hierarchy, and implementing great accessibility, agents are going to be able to use our website better. So, I guess we're done today, right? So we can just go and watch Germany play Ecuador, maybe?
We still have work to do.
All right. Actually, well, as much as I like football, there's still a challenge to discuss.
Yeah.
You see, as humans, when you visit a hotel website and you want to book a room, and you need to understand where the search bar is, or where to pick dates and which buttons to click. And while different sites will have slightly different experiences, you can carry over experiences across websites. So you look at a page, you tell where the search bar is, then you type the location, you click on the search button, then you see the search results, right? And you may have a preference. I know Kasper likes to go to the gym, so he'll probably pick a gym. And we may want to do like a late checkout, and you parse through the filter selection and you click whatever you want. And the user journey can become more and more complex. And as the user journey becomes more complex, the context that the agent needs to know to understand what's going on grows. It needs to synthesize the signals, screenshots, DOM, accessibility tree, but that context is growing. which requires more computing power, which means it takes longer. And at the same time, it increases the chance that the model can misunderstand some signal and take a wrong turn. So here's the question. How can we make the interaction between the website and an agent faster and more reliable? Kasper, I'll leave you to that one.
That's a very good question, right? So, enter WebMCP. WebMCP is a proposed web standard that aims to expose structured tools to AI agents on currently existing websites. What does it mean? It means that when user wants to add a certain kind of pizza to their on your website to their cart, in addition to analyzing visuals of your website, reading DOM, and reading accessibility tree, agent can use tools provided by your website. Right? If there is a tool that agent can call to support user intent, the whole journey becomes simpler because the tool is right here. Of course, we would not be ourselves if we did not show you some demos. So, back to you, Andrea.
Right, thanks. So Kasper is great. He promises demos, challenges the demo gods, and he's like, go for it, Andrea. Great.
I'll try to.
So nice of you. All right. So here's our first demo. This is Le Petit Bistro, and it has a form, as you can see, and you can on the left side, you can see it's a debugging agent we have created. It will list the tools you have on the website. That's what we have, a book table Le Petit Bistro tools. And you have the name and the description. We'll go more about it later. But I can prompt this agent. And I can say something. Caps lock. Celebrating a successful workshop with Kasper at 7 p.m. Book a table in the name of Andre, and that's it. And we can tell the agent is going to call the tool and fill in the form for me: name, date, time, number of people, and then even the special request. We are celebrating a successful workshop. That's it. Let's go to the next demo. So, all right. So in this case, this demo is a game. The game, the tools you have in this game are, you can move your character around. You can look around, which means that it will give the agent information about what's around your character. It can pick up items. You can use items, and it can drop items. So that's what the agent can do. So let's see what happens. I'll just tell move down and see if the agent does it. Yep, just did it. I can tell it moved down. You can see it invoked a tool called move and the parameters solve. And I can say, oh, there's a key over there. So let's say move down and pick up the key. All right, just picked up the key. Green key is over there. Well done. Okay, move down 2 times. We'll do it. Yeah, great. Let's do it. Then move right. Open door to the north. Let's see if it does that one. Yeah, did it. So this gets boring pretty quickly, right? So what if we try something slightly more complicated? I mean, let's try the exits of the maze is at the bottom, right? So I created it so I can tell the agents. Keep moving until you reach the exit. Pick up items you find and use them to unblock your path. Avoid backtracking. All right, some slightly more complex instruction. Let's tell the agent to go and see what it's going to do. So, yeah, it's moving. So what's happening here is I gave the agent much more complex instruction, higher level instruction, and it's figuring out how to combine the tools that I provided in the page to solve that higher level problem. So imagine that if you're doing that on your website, how the user can use your tools in creative ways that we maybe haven't even imagined. So we're not going to wait until the agent reaches all the way to the end. Maybe it's even stopped right now, but we can switch back to the presentation. You've seen what you can build with WebMCP. Now, let me give you a tour on how to define tools. First, you have two ways to do it. You have the imperative API, which uses standard JavaScript. And you have the declarative API, which uses additional attributes on HTML forms to implement WebMCP. So let's take a look at the imperative code first. So, yep, that's all there is to it. And let me give you a deeper tour. So to register tool, you call documents.model.context.register tool. Your tool needs to have a name, a description, an input schema, and an execute block. The input schema are the parameters the model will pass to your function when executing the tool. The definition is a JSON schema, which is a powerful format, and you can find details about it on json-schema.org. The execute block is what will happen when the tool is actually called by the agent. You may have noticed there is that add to do item in there and wondering, what's that? That is just your real JavaScript function. And it can be any function your site already has, or it can be a new function you want to implement. The value returned by the execute block will be sent back to the agent, and the agent might send that back to the model. This is a great opportunity. For instance, let's say that there's some error in the parameters, or you want to report success or even next steps to the agent. You can return that information, because remember, that message is not for the user. The message actually goes back to the agent itself. So you may want to unregister tool, right? If you want to unregister tool, you can use an abort controller, and you pass it to the register tool when registering it. Then when the tool is no longer needed, all you have to do is just abort the controller. For example, if you are an Angular developer and your tool availability is coupled to your component lifecycle, you can use the onDestroy hook to do that. Then we have the declarative API. If you already have a form, you only need to do a couple things. There are just two required attributes, tool name and tool description. When you provide them on the form, your form will be seen by the browser as a WebMCP tool. Two-parameter description is an additional attribute, but it's optional. It gives the agent needed context about how to use that inputs. That's an interesting thing to remember. The way you name your tools, the way you describe them, the way you describe parameters is not just documentation. It's actually important context that the agent will use to decide when to use your tool. Think of it as some specialized form of prompt engineering. So on the right-hand side, you can see how the browser will translate the declarative tool we just registered into an internal representation. And that internal representation is very much like the JSON schema that we use on the imperative API. So you have tool name, tool description, parameter description. Okay. One thing to know is that the default behavior for the declarative API is that they require user action to submit the form. The agent will only fill in the fields. The user will have to click on the submit buttons. But you can change that behavior with the tool auto-submit attribute, which allows the form to automatically be submitted once the agent fills all the information. Finally, there's a new member added to the form submit event called agent invoked. So the value will be true when the form submission was filled and invoked by an agent. You can use that, for instance, to validate your form and then use the respond with method to return detailed message to the agent so it can learn about its mistakes and try again. Now, we just scratched the surface of the imperative and declarative APIs. Enough for the workshop, but if you want to learn more about more advanced features and ways to use the API, you will find more details here. All right.
So let's try this in practice. So you have two ways of solving this workshop. The first way is we provided you templates in the code that already have things like input schema and so on. The things we need to do is uncomment them and add proper tool names and tool descriptions. And we have to be very precise to distinguish between tools like edit to item and toggle item. Toggle is kind of editing, right? The other way in which you can solve the workshop is by using modern web guidance. I believe some of you have seen the earlier presentation today. So my tip would be very specific about what needs to be accomplished, right? Using modern web guidance, wrap those specific functionalities into the WebMCP tools. Let's switch to the laptop. Alrighty. So this is a meta demo, let's say, because it also serves as a to-do list for this workshop, right? So we have several things to do. Implement imperative WebMCP tool, validate it with DevTools, implement declarative WebMCP, validate it as well, then debug. And one is hidden, Lighthouse Agentic Web audit. We will be running audits. All right. So let's go to the code. So in the app.js, in the base directory, to-do list, you have commented out templates for the WebMCP tools. If you want to use modern web guidance, you can just completely ignore it, delete, and use the WebMCP skill to implement those tools. But let's try to actually uncomment them. And first thing I want to do is the get to-dos, right? The first thing I need to feed to the agent is get to do. And for this, I also want to understand like how to do is constructed. So it has ID, text, and status, right? So let's description returns list of to-dos with their ID, description, and status. Let's save. This website is being run with on port 8089 with cache disabled. So if I reload it, I expect the tool. Yes, the tool is there. So let's try to trigger it. So list me only descriptions of current to-do items. I will maybe clean this list and let's try it. All right, so at the bottom you can see AI result, implement imperative, blah, blah, blah. Got it. First exercise done. So now it will be good to have some tool to actually mark this exercise as done, right? So let's try it. Down below you will find toggle to do. So let's do it. Let's try to uncomment this. All right. Toggle to do. Toggle is the status of a to-do item between active and completed. Okay, so in this example, we are using toggle. But let's say to the agent like mark, implement imperative WebMCP to do as completed. Yeah? Nice. We have this one as well. Let's try to implement just other tools as well. So add to do, starting with add to do. All right. Add to do, okay. Add to do to the list. Fair. Edit. Selecting, still selecting. All right. Will it suggest me something? Yes. Edit the text description. That's important, right? Because that's what will distinguish between editing description and toggling the status, right? And delete. So, Andre, we have so many cool tools. What to do we should add?
I mean, we already booked a dinner, right? So maybe have fun.
Have fun. Yeah, that's a good item to have. Yeah, like add have fun item to the list. Okay, but if we added have fun, unless we mark it as done, are we not having fun?
Yeah.
I mean, continue having fun.
Yeah,
so let's edit the text.
Definitely.
Right? Edit the have fun description into continue having fun. Right? Yeah, and then maybe just delete implement imperative WebMCP item. Right? The way it's all right. Let's try again. Delete implement imperative WebMCP item. Delete it. All right. All right. So now what we can do is we can look at the DevTools. I will check later. Why did it catch me? Maybe we need smarter model, 3.5. Let's try this once again. Delete, validate with DevTools imperative. Let's see. I did not add the tool. Okay, that's my bad. There was no tool to delete. Of course, delete to do. Delete is specific to the item. All right. There's some typo. Alrighty. It makes sense, right? It couldn't delete it because I haven't added the tool. So let me try this again. Delete, validate with DevTools imperative. Do I have the? Okay, I need to refresh the page. So the tool is yes. It's now here. It takes some time, but in the meantime, what you can see is that in the DevTools you can see what tools were called, with what input parameters, and with what output parameters. What's also possible is that you can remember that WebMCP tools are either JavaScript based or HTML form based, right? So you can debug them the same way as every JavaScript function that you ever created, right? So what we can do is from here. Oh, now it works. Well, thank you. Live demo, always easy, right? Yes, I do want to confirm. Alrighty. So what we can do is we can select a tool in the DevTools to see where it's registered in our code, right? So let's try it. So it's here, all right? So I want to set the breakpoint because let's say something doesn't work. I should have done this with the delete tool, right? To check why it didn't work. All right, so now let's try to add debugging in progress item. Send. Waiting for the agent. If it takes too long, we will switch the model. Might be. Right, it works. So any technique you already use to debug your JavaScript functions, you can apply for the WebMCP as well, right? Then there's very interesting discussion about the evaluations in general. So I'll be sharing some materials about this later. My guidance would be to test deterministically your tools wherever you can, and then evaluate the touch points with LLM. Like, can agent, given the list of tools, can agent choose the correct tool? Can it choose proper parameters? Can it use one tool result as an input to another tool, right? Like a touch points with the agent. So yeah, I think we are pretty much done with the imperative API. I will just resume debugger and let's go to another demo. I can just go to Google Advanced Search website. This is a real website, right? Then what I can do is that I can try to find the form. Yeah, there it is. I mean, it's pretty small, but yeah, you can see it. So it's a live website, right? And currently, no tools are registered, right? So what I can do is edit as HTML, add a tool name equals advanced search, and tool name description. That would be best improvised search tool. Okay. Okay, tool, of course, the parameter is wrongly named. Tool description. Right? And it converts any form into the WebMCP tool. So, what we also can do is review what's available in Chrome starting from milestone 150, which is the new category of the Lighthouse audit, which is the Agentic Browsing. Let's try to run it on this demo website. What it checks several very, very important things, like accessibility, which is very relevant for agents, right? The content shifts, so how much the content shifts on your website, and validation of things like WebMCP tools. Are the schemas correct, and so on. It's also important to mention that this audit is experimental, and we are looking for your feedback. So let's see. 2 out of 3. Still, it seems that I will have some work to do after, right? To fix the layout shifts for this website, right? So WebMCP form coverage, 2 forms are missing annotation because we did not use the Declarative API. In this example, we use imperative API, so this is informative, right? There are WebMCP tools registered, which is good. And yeah, accessibility tree is well formed and WebMCP schemas are valid. All right. I think we can go back to the deck. So let's summarize. Andrea?
Still here, not hiding behind you. All right, let's summarize. We began by understanding how an AI agent sees your website, how it uses a combination of screenshots, the DOM tree, and the accessibility tree. And so that agentic readiness starts with the principle that we already know: build it well, build it accessible. We have reviewed WebMCP, a proposed web standard aiming to expose structured tools for agents on existing websites. I really encourage everyone to start experimenting with WebMCP and join the Origin trial. Give us feedback. We really want to hear that. If there's a time to give feedback and improve the API, that is now. Finally, we discussed the new Lighthouse audit for the Agentic Web. And we'd love to hear your feedback also on the WebMCP debugging tools available in Chrome DevTools.
Yeah. So the practical steps to make your website ready, it's a good moment to take a picture. So try WebMCP imperative and declarative APIs, audit your website for agentic readiness using Lighthouse, and of course, join the WebMCP Origin trial. Yeah, so Andrea, that's a wrap, right?
Thank you for listening.
Thank you.
Thank you.